For question 14.21, we're given the following reaction. 2 molecules of sulfur dioxide reacting with oxygen to produce 2 molecules of sulfur trioxide, and we're given the Kp for that at 2.5 times 10 to the 10th. And then we're asked to calculate the value of Kp for the reaction of 4 molecules of sulfur trioxide breaking down into 4 molecules of sulfur dioxide and 2 molecules of oxygen. And we're asked to determine the value of Kp. So for that, we need to look at how can I rearrange the first equation to give me the second equation, and then based on that, what would I do to the value of Kp? And so first I would take note that in the reaction that we're given, we're looking for sulfur dioxide as a product. In the reaction that we know the value of Kp, sulfur dioxide is the starting material. So the first thing we should do is flip the reaction. So we're going to flip the reaction and turn it into 2 molecules of sulfur trioxide at equilibrium with 2 molecules of sulfur dioxide and 1 molecule of oxygen. And if I flip the reaction, that's the same as taking the inverse of the value of K. So the new K would equal the inverse of the K value from the previous reaction. So 1 over 2.5 times 10 to the 10th. So I can calculate that. So the Kp for the reaction now is approximately 4 times 10 to the minus 11. Well, I've got one more step because the reaction I have isn't quite the reaction I'm looking for. I'm looking for twice the reaction. I want 4 molecules of sulfur trioxide, not 2. And so that means we need to multiply the whole reaction by 2. So twice the given reaction. And then we think about what that means for the value of Kp. So if I multiply the entire reaction by 2, that will give me 4 molecules of sulfur trioxide. That will give me 4 molecules of sulfur dioxide and 2 molecules of oxygen. And that is the same as squaring the value of Kp. So my final value of Kp would be 4 times 10 to the minus 11 squared, because if I multiply the entire reaction by 2, that's the same as squaring the equilibrium constant for that reaction. So the final equilibrium constant should be 1.6 times 10 to the minus 21, or 1.6 e to the negative 21. So if you know the equilibrium constant for the forward reaction, we also know the equilibrium constant for the reverse reaction. We would just take the inverse of that value because we're flipping our concentration of products and our concentration of reactants. Our numerator and denominator are flipping, so it's the inverse. And if we multiply by 2, it's the same as squaring that equilibrium constant. Or if we divided by 2, right, that would be the same as taking the square root of the equilibrium constant. So we should be comfortable manipulating these reactions and the equilibrium constants to determine the equilibrium constant for a new reaction.